Right, thank you, and thank you to PT Index Commoditas Indonesia and the Petromindo Group for this opportunity to address you. It's still a surreal experience talking to a computer screen instead of talking to a room full of people. I'd also like to thank the sponsors for their support. The scene that we have currently now in terms of nickel mining and nickel processing is that, as you've heard from the previous speakers, the nickel laterites are being used to produce both stainless steel and for the battery metals industry. The battery metals industry, the projected demand is really driving a lot of the cost, a little of the price at the moment of nickel, and the government of Indonesia is committed to developing the downstream industries, which that commitment began with the export ban, and it was clearly explained in the background for this webinar in the piece provided. The one issue I'd take with the background is that the statement was there that nickel is a key material in making lithium batteries. You may recall Elon Musk last year referred to the fact that lithium-ion batteries should really be called nickel-ion batteries because they are mainly nickel. And with the movement towards the 811 battery, we're seeing 80% nickel in these batteries. So I think nickel is the key metal and has been identified as such by various governments in adding it to its strategic metals list. Right, just go to the next slide. So 2030, the UN agenda, the deadline for sustainable development. What does this mean for the battery metals industry? Well, by 2030, many governments, almost all governments, have stated that by 2030, they'll no longer be selling petrol or diesel vehicles, and the only vehicles available will be electric vehicles as new vehicles. In order to get people to purchase electric vehicles, there's an issue with price. Unfortunately, the majority of the world isn't going to be able to afford to drive Teslas, as they are a elite vehicle. And mass adoption has to be achieved by providing the range of vehicles, that we see in the petrol and diesel range now. In order to get the mass adoption of those vehicles, we need the batteries to be cheaper, because the batteries are one of the single largest cost contributors to the price of the vehicle. And in order to get cheaper batteries, we need nickel to be cheaper, because nickel is the largest cost contributor to the price of the battery. Now, unfortunately, a lot of the commentators are saying that the nickel price actually needs to be higher. And you've seen the charts in the earlier presentations suggesting that nickel price is on an upward trajectory. And if the nickel price is higher, then we have a paradox, and that is achieving mass adoption of vehicles by having low cost vehicles, whilst when the nickel price is working against that. The reason in the industry that the nickel price would, why the industry would like the nickel price to be higher, is to justify the capital investment that's required to build the plants. I won't spend too much on this. We've all seen these charts before. As you've heard, stainless steel does consume around 70% of the total nickel produced. And that is likely to increase over the coming decade as we see more urbanization in countries, particularly in Africa. So everyone is heading to Indonesia. Why? Because Indonesia is a very, or perhaps the most viable option for meeting the nickel demand that the world needs. The reserves in Indonesia, if you look at the government's figures, we have reserves of 1.4 billion, 6 billion tons, to be precise. If you are looking at a cutoff grade above 1.7% nickel, and that increases to adds another 2.92% if you go below 1.7%. Of course, the bottom grade that is taken into account of these figures, I'm not able to find. But I'll come back to grades when I start talking a little bit about the process that my company has developed. This figure from the USGS shows clearly that Indonesia is the largest source of nickel in the world. The tonnages, if you take 23.7% of 88.7 million tonnes, you don't come out with the numbers I've just provided, but that is dependent upon where the source of the numbers. So world nickel production, Indonesia is outstripping the rest of the world. It is producing over 2 times more nickel than any other country. The issue here, though, is that nickel processing, nickel mining and nickel processing, there is an environmental cost. And whilst I can't talk about the mining, as that's not my area of expertise, in terms of the processing, it's important that we understand that nickel is being provided, nickel for the battery metal industry is produced by the hydrometallurgical industry largely. We've heard about the Tsingshan process for taking nickel pig iron and converting it to matte, but I don't think that's a viable long-term process. Hydrometallurgy is the choice, and that of course is a chemistry involving the use of acids. And there's also recently been a debate about the deep sea nodules, which are an alternative to laterite ore. The nodules being harvested off the ocean floor. You'll have heard, I think it was earlier this week or late last week, that BMW and a number of other motor vehicle companies came out and announced that they would not touch any metals that were sourced from those nodules. Now, the companies involved in the harvesting of those nodules have pushed back and made a comparison between the environmental impact of the harvesting of nodules versus the environmental impact of land mining. But this all goes to demonstrate the fact that there is an intense focus on the environmental impact of the production of these metals. If the world is seeking to adopt electric vehicles for the purposes of creating cleaner air and meeting climate change targets, destroying the environment at the outset in the mining and the processing of those metals would appear to be counterproductive. And I don't think that's what is intended by anybody in this industry. So as I said, hydrometallurgy is the process by which MHP is produced, mixed hydroxide product, nickel cobalt mixed hydroxide. At the moment, that process is largely produced by HPAL, and HPAL being an established technology. We're plants here in Indonesia and elsewhere around the world. You've seen in earlier presentations, there are some issues with HPAL, cost overruns, failure to meet nameplate capacity. Technologically, it's a complex process, largely driven by the autoclaves that need to be developed. It operates at 400 atmospheres, it operates at around in excess of 250 degrees Celsius. So it's a challenging process. When it works, it's efficient. The one problem that HPAL has, and I know that the Indonesian government is dealing with at the moment, is the tailings. And the tailings have basically, there's 2 things you can do with the tailings. One is you can put them in a dam. So this is a picture of Coral Bay from Google Earth. There is a small processing plant down the bottom, just where the red dot saying Coral Bay Nickel Corporation is. And then there's a tailings dam, which if you use Google Earth's measuring tool, you'll find that's about 1.7 kilometers long and 1.3 kilometers wide. When tailings dams go wrong, they go wrong in a big way. And okay, this was an iron ore dam in Brazil. This was the Vale dam, which burst in January 2019. As you can see, lots of people lost their lives, and just recently Vale announced a $7 billion settlement to compensate the communities that were harmed by that. Another alternative to tailings dams is deep sea tailings placement or deep sea tailings disposal. I think placement is probably a bit of a euphemism, and disposal probably is more akin to dumping. If it goes into the sea, we don't know where it ends up. The green lobbies are clearly very opposed to deep sea tailings disposal, just as they have issues with the mining of the nodules. This is a subject which is not going to go away. I understand the Indonesian government's position is that they're not going to grant permits for deep sea tailings disposal, and which leaves them, what is the option? I'm sorry. Yeah, sorry, wrong picture. And we saw at Ramu the problem with the deep sea disposal is that if something there goes wrong, again, it's rather catastrophic. One alternative for HPAL plants is they can spend another $1 to $1.5 billion and build a tailings treatment facility to enable the tailings to be dry stacked. Indonesia, of course, is in the Coral Triangle, so there's a very delicate environment here, which suggests, is obvious that Indonesia is not well suited to this, apart from the seismic activity in this area as well. As you've heard, there's an alternative, the NPI to MAT process, which Tsingshan announced. The process, I think, is very greenhouse gas intensive. Some commentators have said it may produce localized acid rain. I don't think there is any long-term future for that process, certainly not in the green world of electric vehicles. We believe that we have an alternative, and that alternative is the DNI process. This process has been in development since about 2008. It's been waiting for the battery metals industry to develop. That's the industry that our process is most suited to. Unique features of our process is we treat limonite, saprolite, and transition zone in almost any blend. We extract all of the metals that are present in that ore. So the economics of our process are fundamentally different from the economics of any other process, because you don't just look at the value of the nickel, you look at the cobalt, the scandium, aluminium, magnesium, manganese, and very importantly, we take the iron out. And in taking the iron out and producing a hematite, we significantly reduce the volume. So our residue is about 50% of the ore, so about around 450, 500 kilograms per ton of ore processed. And that residue is able to be dry stacked and returned to the mine because we've recovered almost all the acid from the process. We use nitric acid, and the nitric acid doesn't attack stainless steel, so that means that our materials of construction are quite straightforward, 3 or 4 grade stainless steel.
Mr. Gower, your time is 3 minutes left.
Okay, I will move quickly. Last week, Parburas in a presentation showed a calculation of the amount of waste that was produced for each electric vehicle. He came up with a figure of 19.5 million tons. And what he didn't add was the neutralizing agent that has to be added to the sulfuric acid rich waste, which tends to triple the amount, the volume of the tailings. The DNI process, as I've said, it's safer. We operate at atmospheric pressure. We operate at temperatures around 110 to 140 degrees. It's a simple, straightforward flow sheet, and our materials of construction are 3 or 4 grade stainless steel. We have low capex and low opex when compared to, certainly when compared to HPAL. Success stories, recent success story is Queensland Pacific Metals. They have just announced the commencement of their definitive feasibility study, which is being done by Hatch, and they are building the first commercial scale direct nickel process plant in Queensland near Townsville. You can read a lot about them on the website because they're a public company. I invite you to follow me on LinkedIn. We tell our story and we keep it updated very frequently. Each week, and if you'd like to follow us, you'll find me there. And with that, I'll say thank you very much.